As we know that although Nepal is rich in made a remarkable progress in drinking water quality sector from past few decades, however, the status of the drinking water is poorly documented and less known. Even though we have some data, is rich in water resources. It's about 6,000 rivers in Nepal, and the surface water available is 225 billion cubic per meter annum, out of which only 15 billion cubic per annum is in use. And in here you can see the data of the lake is about 5,358. During that inventory period, Dr. Vuzu team, as we are all the team members of the Dr. Vuzu, and I also went to Nuakot to find out the lake situation of the lake, and we also find out explore the one lake during that time, which was Kalital in Nuakot, which was also explored by our team, and which was led by me during that time. And it is one of the very important documentation. During that time, we did it. And the total water supply systems and industries use is here you can see it's very less, even though we are not getting a very good quality water. And this is very common media coverage every time in Ravati residents real under a shortage of drinking water, like this thing. Health official says that the waterborne disease is very much higher, and also infected with the children, and like these things. This is very common. And what are the challenging for achieving the target of SDG 6? Actually, we are rich in water resources, but the poor management system is also one of the factors that we are not getting the good quality as well as the good quantity of the water. And the drying of the water resources sources is very common problem. Whereas because of the overpumping of the groundwater system, likewise, we are using a very old distribution network system in Kathmandu. And the leakage is another problem where the KOK data also say that more than 35 or 40% water were leaked every day. And another problem is the dumping of the solid waste nearby the surface water. Here you can see in the Chobar region, the solid waste was dumped, and without any treatment, the wastewater was discharged into the water. These are the main sources which cause the pollution. And also the inadequate infrastructure for water treatment and wastewater treatment. And because of all this higher demand, water demand, and you can see in the figure here, there is so many forests of the house, urban population increases. And another problem we are facing here is the climate change. And climate change associated global warming are also likely to affect the availability of the water in the future. Here, this picture is very much one of the emotional picture that we are saving the money for our children, but we have to think about the environment, think about the how to save the environment. This is more important to save the money. Now we all know, most of the people now, we are very much concerned about the SDGs, and the SDGs are the blueprint to achieve a better and more sustainable future for all. They address the global challenges we face, including poverty, inequality, climate change, shortage of water, and so on. And its SDG is aligned with the 5P: people, planet, prosperity, peace, and partnership. And this is very important, that better world ways, but only if we act fast, because we have only 7 years is remaining to achieve the SDG. And therefore, what we need to do, the more research activities should be focused to achieve all these things. Here you can see in the clean water and sanitation. If you don't have a water, and we will face the poverty. Likewise, zero hunger. And if no water, we don't have a good health and not a quality education, and also gender equality, but they don't get enough time to have their education, as well as gender equality and climate change and so on. Therefore, all goals of SDG are linked with water. And I always say that the research is global, service is local. So that we need more research, and water research for problem solving can be broken down into a number of separate components, which each of which requires information and analysis, and identification of the problem, diagnosis of causes, identification of potential solution, decision for action, and monitoring and evaluation of actions and outcomes. And I just like to show that some trend of this water quality of the Kathmandu from 2009 to 19 is a 10-year samples, and they show that the most of the groundwater samples, just like 50% of the groundwater samples were contaminated with iron content, as well as the ammonia is also there, and the turbidity, coliform bacteria, and the main concern about the groundwater quality is also contaminated with the total coliform bacteria. And total coliform bacteria, we tested the total coliform bacteria in the laboratory because of the easy to detect, and this is the indicator organism. If the coliform bacteria is present in the water sample, it said that it might be presence of any other pathogenic bacteria, because it's very difficult to detect the other pathogenic bacteria from the water. So we used to test the total coliform bacteria as well as fecal coliform test in our research laboratory by membrane filtration technique. And we did some monitoring of water quality of this, so that the from the supplied water by Kathmandu Upadhyaya Khanepani Limited, which is the supply system of the government supply. It's a semi-government supply system from Kathmandu, and we saw that the Balkot region, the coliform count is very high, and in Takesu, 94% samples exceeded the standard, whereas in the from the Keukil supplied water, we took the sample from the Kulesur, Balku, and Soltimur, and it said that the 40% samples had a coliform bacteria. This, in comparison with this place, the Keukil supplied given water is far better than other places. And also the Bhaktapur water, it's from tap water, well water. We determined many parameters tested, and we found the E. coli, Enterobacteria, Citrobacteria, Enterococci in the water samples. And also the another problem for this is the antibiotic resistant bacteria in groundwater. And here you can see that the resistance is the red one is the resistance pattern. The cefazolin is more resistant to the bacteria Klebsiella. Here also you can find that the well water and the comparison between well and the boring water, the frequency of resistant bacteria in well and boring water, and the susceptibility pattern of the Klebsiella pneumoniae. And other parameters also say that the higher number of percentage of the coliform bacteria in well and boring water, it's very maximum percentage exceeding the national drinking water quality standard. It's 98%, whereas for other parameters like ammonia, iron, and iron turbidity is also one of the major problem. Likewise, we not only categorize the tap water, we also did the work on river water quality evaluation, and we did 13 different sampling sites from Sundari Jal to from the upstream to downstream, and in the middle region it showed that the COD is very extensively source, but the pollution is not so much problem. But when it was in the urban region, the problem is very extensive problem. And another also the I just forget it. The importantly that in antibiotic resistant pattern, ARG antibiotic resistant, so that 20% of them are MDR, is a multi-drug resistant, and this is also one of the big problem of the environment. If this antibiotic resistant pattern it will be increasing, there will be the very much alarming situation for the public health. And another research aspect in the arsenic in groundwater, so that the higher arsenic was detected, it's 2.07 milligram per liter. After 10 years also, we detected the again higher was milligram per liter, 2.8 milligram per liter of the arsenic is detected. Uh, and we also not only focus in the Kathmandu area, we used to take a sample from the different region. Like last year, I went to this village to take a sample, and we collected a 15 water sample from the tap water, spring water sources, and we analyzed this water in the field also, and also so this how to test water to the school children, and also interact with the general people, consumers. And we tested different parameters, physical, chemical, and also tested heavy metals. And for the microbiological also, coliform count, and E. coli count, fecal coliform count, and the others identification of the others pathogenic bacteria. And we did this work also in the field, middle of the field. This is a recent research from the Dolpa in Dhodhara Valley of the Dolpa region. Here we collected a 12 number of samples, 4 from the river, 4 from the tap water, and the 4 from the spring water sources. Chiring Dorje, he's one of my student collecting water sample. And here we found that the most of the samples were within the standards for the case of physicochemical, but in the coliform bacteria is also this dolpa is also not so much pure to drink water. Here 83.3% is water sample was contaminated with coliform bacteria. And one of the another research aspect that we did analyze, we find out, we analyzed the microplastic in the Fewa Lake. Here, one of my PhD students, she recently completed her PhD to conduct her research in microplastic with a 5 publications. And this paper showed that the first report on abundance and composition in surface water of lake in different region, and the microplastic research is very few in Nepal, where we also did this work in our research laboratory. And this paper was published in Environment Science and Pollution Research, and this is also water, air, and soil pollution. These are some photographs. My students, they involved in the various activities to analyze the monitoring the water quality from different sources, like from the Himlung, Himal, and the Mira Peak. From this region, we find a very good quality of the water. It's no contamination of the coliform. This is the good signal that in the Himalayan region is still pure from the microbially. And this, I would like to share this data. And here from the Darildura Alital, and also Kanchanpur, and also from the Dolpa, Pokhara. So he's one of my American students came to my lab to do some water related research work. And in Kankai Japa, and we are collecting the water samples in Bhaktapur region. And also we are analyzing the water sample from the bottled water of different places. And stone spouts from different area of the Kathmandu Valley. And two of my PhD scholars, they are focused on working on the microbial community structure and antibiotic resistance in hospital wastewater. And this results show that we are finding some antibiotic resistant gene, which are circulating from environment to water. and also went to the cistern site to collect the water sample, leach it, and also to find out how to solve the problem of the odor. Also, still this work is going on. And regarding the purification steps, as I got one fellowship from the Organization for Women in Science for the Developing World Early Career Fellowship, and from this also we have started to do some work on it, and we prepare different kind of the adsorbent. These are the adsorbent, these are the water purification material, and it's a different it's a chemical as well as the biological material, where we use to treat the organic arsenic and inorganic arsenic. And the adsorption process was used because they are very economic to use, easy, and also easy to operate, and environmental friendly technique. And this all experiment we are doing in a batch experiment process. And after preparing this adsorbent, we used to characterize this adsorbent by different technology, and did a batch experiment like effect of pH, adsorption kinetic, adsorption isotherms, and also to find out the removal mechanism by using the FTI technique, and the characterization by using the XRD. And here, from my grant, from my fellowship, I was able to buy this equipment, Zeta Potential Nanoparticle Analyzer. In one fiscal year only, we tested 119 samples from the different research scholars, master student, PhD scholars, and the researcher from different institute, like the from the Tribhuvan University, from Kathmandu University, Agriculture Forest University, Institute of Engineering, our researcher, as well as from the research institute like RIB. And we are providing this to them. Actually, I provided this service free of cost also, because as I got this as a grant, so that I would like to support to other researchers. And this is only one equipment installed in Nepal in research institute, like research institute. And because we don't have this equipment before, therefore it is very convenient for other researchers. And after getting this equipment, they also published a very good paper in research article. And other removal, turbidity removal by using alum. This is just recently done by the physics student. She did prepare the different kinds of turbid water sample. Actually, she collected the water sample from the different sources, actually, which has a high turbid water. And then she put some alum to treat it, and she find out that after the overnight sedimentation, the turbidity removal efficiency was high. And she not only did the turbidity, but also find out the optimization process by using this Zeta Potential Analyzer. And if the alum dose was high, and it gives a positive value. If it has a low, and it gives a negative value, and it's like 0.5 per gram per liter is optimized value for the turbidity. And it also depends upon the turbidity. Some of the messages again goes to the SDG. In order to achieve SDG, water associated goals must be targeted, to which water research could be important asset. There are challenges in water research in Nepal. I have already mentioned about that. Although Nepal made a remarkable progress in the developing drinking water sector from past few decades. Here, everyone house has in the village also, everyone home has their own tap water and getting enough water. However, we have to face them some kinds of the quality problem. Therefore, sufficient fund must be invested in water research. There are tremendous opportunity in water research in Nepal. However, there is a need to invite more researchers in this sector. And one of the most important is the behavioral changes are also required for a new water culture and the attainment of the water and sanitation goal by 2030. And I would like to thank these young researchers for always with me, and I'm working here day and night for the future of my young generation. And thank you so much.